everyone. Today, we will learn step-by-step SPSS data analysis with a statistical test, the Mann-Whitney U Test. At the end of this video, there is an exercise and you can download the data for the exercise and practice your data analysis skill. So, let us start. The Mann-Whitney U test is a rank-based non-parametric test used to determine if there are statistical significant differences between two independent groups of an independent variable on an ordinal scale-dependent variable. It is widely used in data analysis with ordinal scale variables using the Likert scale. For example, the 5-point Likert scale labeled as 1 equal to strongly disagree to 5 equal to strongly agree. It can also be used to replace the independent sample t-test when the dependent variable is in continuous data, but not normally distributed. T-test requires the dependent variable to be normally distributed. In short, the function of the Mann-Whitney U test is similar to the independent sample t-test, but the difference is the data of the dependent variable for t-test must be continuous data that is normally distributed. But the data of the dependent variable for Mann-Whitney U test is not required to be normally distributed. Hence, the Mann-Whitney U test is a non-parametric method to the t-test. It is also called the non-parametric t-test, Mann-Whitney-Wilkerson test, Wilkerson rank sum test, or Wilkerson-Mann-Whitney test. The independent variable is a grouping variable with two groups. Examples of grouping variables are gender, labeled as 1 equal to male, 2 equal to female. Age level, labeled as 1 equal to less than 20 years, 2 equal to 20 years and above. Field of study, 1 equal to sciences, 2 equal to non-sciences. And education level, labeled as 1 equal to undergraduates, 2 equal to postgraduates, and etc. Because the Mann-Whitney U test is a non-parametric test, there is no normality assumption of data. The following is an example research of data analysis using the Mann-Whitney U test. In this example, a research is conducted to investigate whether there are differences of emotional intelligence between psychology and business students, business and computer program students, psychology and computer program students. In this research, the independent variable is field of study and the dependent variable is emotional intelligence or EQ. The objective of the research is to compare emotional intelligence between field of study. The two variables in the rectangles and the single-headed arrow form a conceptual framework of this causal-comparative design research. The research data is collected from 80 students, 39 psychology students, 19 business students, and 22 computer programming students, using an emotional intelligence questionnaire. The data collected is tabulated. We will use this data for analysis in SPSS. Before analyzing the data, the researcher needs to state the research hypothesis for hypothesis testing. There are three hypotheses. The non-hypotheses are: there is no significant difference in emotional intelligence between psychology and business students, business and computer programming student, psychology and computer programming student. The research hypotheses are: there is a significant difference in emotional intelligence between psychology and business student, business and computer programming student, psychology and computer programming student. The null hypothesis is true if p-value of the Mann-Whitney U test is larger or equal to 0.05. However, if the p-value of the Mann-Whitney U test is smaller than 0.05, the research hypothesis is true and we will reject the null hypothesis. This concept must be very clear before we analyze the data in SPSS. Now we will analyze the data using Mann-Whitney U test to test the research hypothesis. To analyze the data, open the data in SPSS. You can learn the steps of entering this data in another video Kruskal-Wallis hashtag in my YouTube channel. In this data, the first variable is group. Then we have 5 EQ items in 5 points Likert scale. And finally, we have the total score for EQ. It is the result of summing the 5 IQ items. To view the variable labels, click the variable view button. In the group variable, we have 3 groups: psychology, business, and computer programming. For total EQ, it is the result of summing the 5 EQ items. Note that all the EQ items are in ordinal scale and the group variable is in nominal scale. To analyze the data, click the Data View button. Click the Analyze button. Select Non-Parametric Test, Legacy Dialog, and 2 independent samples. The test variable is the dependent variable EQ. Select EQ and move it into the box. To enter the group into grouping variable, select Group and move it into the box. Then click the Define Group button, type number 1 and 2. In the group data, number 1 represents the psychology group and number 2 represents the business group. Then click the Continue button. Ensure that the Mann-Whitney U test is selected. Finally, click the OK button to get the result of analysis. The rank table presents the sample size and mean rank for the psychology and business group. The test statistic table presents the Mann-Whitney U test result for hypothesis testing. To compare the business and computer programming group, return to the SPSS data again. Repeat the process. Click Analyze, select Non-Parametric Test, Legacy Dialog, and 2 independent samples. Click the Define Group button. Change the numbers to 2 and 3. 2 is for business group and 3 is for computer programming group. Then click the Continue and OK button. The output presents the comparison between the business and computer programming groups. Return to the SPSS data again. Repeat the same analysis process. Click the Define Group button. Change the number to 1 and 3 for comparison between the psychology and computer programming group. Click Continue and OK to get the result. The result for comparison between psychology and computer programming are obtained. Let me delete the syntax and the titles so that we can see the table clearer. Finally, these are the results. And let me elaborate the result one by one now.